All right, hi everyone. Such a big turnout, that's great. My name is Wojtek Kaliciński. I work for Google in the London office on the Android Developer Relations team. And today I came here to talk to you a little bit about Apps Vitals, or Android Vitals, and what that is. So, what is it? How many people have heard about Android Vitals? A lot. Okay, so you've probably been to this section of the Play Store. Well, it's a little bit cut off. Well, anyway. So yeah, especially if you're an indie developer, if you have your own app, you probably manage the Play Store by yourself. And well, there's this new section since Google I/O last year called Android Vitals. It tells you a lot about what's happening with your app in the wild on users' devices. So I'm not going to show the interface too much because that's constantly evolving. We'll be changing it. There's new sections being added. But I'm going to talk a little bit about the vitals themselves. We also call them known bad behaviors sometimes. So what are they? So you probably read my talk description. I made this analogy between the human body and vitals and the app. And well, what I want to say by that is, sometimes when we are not feeling very well, we have a headache or something, we think, well, it'll pass. Or maybe we'll go see the doctor then if it's really bad. And then again, for months we might be okay. And then, when something happens, we'll go get over it. But what would be even nicer if, there was someone to tell us what's wrong and when we actually have to take action. And I think that's the big important part about Android Vitals. It's a section on the Play Store that tells you how your device, how your app behaves on users' devices, how many crashes it has, how many frozen frames, how well it works. And it's impossible to test that in lab conditions. And maybe when working on your app, sometimes you'll think, maybe it's not as fast as I'd like. Let me go and debug this. And then you forget about it again. And it's really all about that hygiene of knowing what's wrong at all times and knowing when to focus and where to focus your attention and on which performance problems of your app. So Android Vitals currently is all about three things. First of all, it's about stability. Does your app crash a lot? Does it throw annoying dialogues like application not responding to your users so that they then close or wait and get very frustrated? The other part is battery. So every user cares about battery life. Everyone would love their phone to last throughout the day and even the night. But all it takes is one app that does the wrong thing, and one app can take the whole phone down within hours, or if it keeps constantly waking the phone up, keeps running in the background, and so on. And the third one is rendering. So this is mostly about the smoothness of the UI, or what we call jank, like if it's janky, if when the user scrolls a list, if it's a smooth motion or not. And because this is such a huge topic, I'm mostly going to focus on the first two, stability and battery, in this talk. And there's so many resources about rendering and debugging your UI out there that I'm just going to literally just point you to some tools that you have. So this is how currently, more or less, this is like a mock-up, the Android Vitals section looks. And at the top you might see there are these tabs with all the behaviors that I mentioned. So crash rate, ANRs, frozen frames, wakeups. I'm going to go through some of them today. And what you might notice for your apps is some of them might be missing for you. So for example, if you're not using wakeups at all, then you might just not have this section. Or if you don't have ANRs. Although probably most apps will at least have crashes and ANRs. The thing about gathering this from users' devices is we also care a lot about privacy. So if your app has just a few hundred users, maybe it's very new, just released on the market, on the Play Store, and maybe there's very few users on the same device versions of the same manufacturers and so on, then we will not show those bad behaviors to you, those vitals, because then it would be too easy to infer which user had those, and we don't want that. So it only works for really big apps where there's a large user base, you get a lot of reports, and then we collect this information, we identify patterns, and present those to you, and even notify you whenever for example, your crash rate reaches a certain threshold, and then we say, you have a clearly visible bad behavior there that you should focus on. Okay, I think I should try probably doing something with the text fits. Okay, great. So yeah, first we're going to talk about application not responding events. Probably everyone's seen them. So what is it exactly? ANR, or application not responding event, happens whenever an app blocks the UI thread or the main thread for too long. So when a user tries to interact with the app, they press the screen or press the back button to back out of the app, and nothing happens, and things just seem frozen. You can't do anything, the UI is frozen. That's because you're doing something on the main thread so that the app cannot react to user events, like input events, and it cannot redraw itself. So you just see it the same screen. And after a few seconds, 5-10 seconds, the system will notice that something's wrong. The input events are not coming through, and it'll show this a dialog asking the users if they want to close an app. And, well, that's not something you want for your apps. And the user can even get super annoyed and uninstall it or give you a bad rating. So this is how this might look on the Android Vitals console. There's this ANR tab, and like I said, we try to intelligently cluster the data so you don't get overloaded with everything, every possible ANR. We try to group them logically into groups, devices, and then you can decide which ones you want to go and investigate more. And I'm going to talk about what you can actually get from that a little bit later. But now let's focus on, how do ANRs happen? So like I said, it usually has to do with blocking the main thread for a long time. So what's fast, what's slow? Well, there's one rule of thumb that probably everyone knows about. Disk network access is slow. Flash drives can be old or cheap, or the system can be doing a lot of other things. And just accessing and reading something from the disk or writing something to the disk is super expensive. It might take a long time, seconds even, if on a particularly cheap device or if the system is very busy. So let's start with a little quiz to show you that even though we know these principles, it's not always easy to actually, as a developer, know when we're doing the right thing. So let's start with something easy. So here in this code, in my, let's say, on create, in my activity, well, I decided I'm going to use shared preferences later. So I'm just going to create this object, okay? And then I'm actually reading something from it. I'm thinking, well, it's just a small integer, so I'm just going to grab it and save it because it's maybe like my user identifier or something. So how do you think, how many of you think an ANR, or a disk access, can happen in the first line where I just create the object, and how many of you think it's in the second line when I actually read something for the shared preferences? First line, show of hands. Second line? Okay, similar to the previous presentation I made. Well, it's actually the first line. So if I just create the shared preferences from disk, the actual implementation eagerly reads the whole XML, even if I just read one integer later. If my shared preferences are large, like there's a lot of things stored in there, you pay the cost up front where you just create it. But it doesn't really matter if my shared preferences are large or not. The sole fact of reading something from the disk, like I said, in particular situations, can cause an ANR, and it's something you should never do on the main thread. So yeah, so this is wrong. The ANR will happen here, or can happen here. Okay, let's try on something more difficult. So here, I'm sorry that you can't see everything, but the main part at least is visible. So let's say this is completely hypothetical. This code doesn't make a lot of sense. But let's say I have some URLs, and I want to see if my activity was open by an intent with a specific URL. So I have this URL, example.com, and I want to check my intent data. If it equals that URL, then I want to connect and download some things from there. Maybe for whatever reason, it's not supposed to be real code. So first I check if the URLs match. If they match, I open the connection to that URL. Then I just save the header fields for later because I might want to read something from there. And then I actually open the input stream on the connection. And finally, I read a kilobyte of data or something. So okay, who thinks it's going to be open connection that blocks here. Okay, next one. Saving the header fields variable to a local variable. Nope. Get input stream. Okay, just 1, 2 people. And actually reading bytes from it. More. Okay, I think no one raised their hands for header fields. This is the one that will block. So, because of the peculiarities of HTTP or a connection on Java and Android, it's only when you actually want to access some information that will come with the request. And response headers, well, you have to connect to the server to get the response headers. And the moment I call the get header fields method on the connection, it'll actually connect, get those header fields, and let me use them. Open connection doesn't actually open a connection. If I didn't have the header fields, it's probably the get input stream that would actually open it once I'm ready to read. But you know what? That's actually wrong on some versions of Android and Java. This line can cause a network connection on the desktop JDK and on some very old versions of Android. I think pre-ice cream sandwich. So in the original equals implementation on the URL class, not the URI, but URL, it actually resolves the DNS names of the host name to check if 2 different host names can point to the same IP. So this is just, you probably don't have to deal with this because, like I said, it's been changed on Android for a long time. But it's just to show that even with, if we think we're good developers, we're trying to do the right thing, not open connections on the main thread, we might trip up somewhere and just not know about it. So how can we deal with that? The answer is strict mode. Strict mode is an API that existed on Android for a long time. And basically what it does is you use it in your debug builds when you're developing, when you're testing your apps locally. And you enable it, let's say in your application on create or activity on create, on your main thread. You set this thread policy, and you tell it, I want to detect disk reads and disk writes. So that would deal with our shared preferences issue, right? And then I want to detect network calls that happened on this thread, right? We're setting a thread policy on the main thread. And then what I want you to do is I want strict mode to tell me in the log cat, whenever I do those things. So if you detect disk reads, disk writes, and network, show me a log. But I might miss a log. I might not care about the log cat. So I'm going to be even more strict. And after that, I'm going to also say penalty death. So my app literally just closes. So now whenever I ran one of the codes that I showed you before and tried to debug my app locally, like run it, my app would crash. I would look in the log, and what I would see is something like this. So there's an exception, strict mode violation, disk read, and it shows me the stack trace exactly when it happened. So here in my main activity on create, I have this get default shared preferences. And on it goes, and it shows you that it actually uses the file APIs and opens the file. So great, it tells me exactly when these things happen, and I can just go and fix them. And one thing you don't want to do is you don't want to publish an app with strict mode enabled for all those things on the Play Store because, well, you don't want things to be crashing for your users like that. They don't care about the information in the logs. And we might add new detection capabilities to strict mode in the future. So let's say even if you enable it now and publish it on the Play Store and nothing crashes, it might eventually in the future. So don't do it. Use it as a local debugging tool. Set it under a flag, in your build. But there's one more thing that strict mode can do for us. I mean, there are many more things. I suggest you explore the API. There's not only a thread policy, you can also set a VM policy that lets you things like leaked, resources of all kinds. But in the context of ANRs, you can also ask it to detect custom slow calls. So what are those? So let's say here I have this sample app that's a Sudoku game, and when you open it, it needs to generate a Sudoku board. And it's actually, well, it's not very difficult, but it takes some computations. I don't read the board from disk, I don't read it from network. I literally just do some mathematical computation in RAM on the CPU to generate a valid Sudoku board. And on a very slow device with a very slow CPU, this takes actually quite a lot of time. And you see here, yeah, ANRs. So it's a terrible experience. The user sees a blank screen. They try to back out by repeatedly pressing the back button, and nothing happens until the app, well, it doesn't crash, but it's almost as bad as a crash, or even worse. So yeah, I thought I can do it in my own create method because I'm not hitting network or disk. Well, if the creator of this Sudoku algorithm would know that this call is super long, maybe I don't know because I'm just using this Sudoku library, but they should know that this takes a long time. So they can add this strict mode note slow call with a descriptive tag, and now if I'm using these custom calls, if I enable those in strict mode, this will work in a similar way as Discord network. So now, even though I wasn't sure if this call is long, is it long enough to cause an ANR, well, now I know. Now it will just crash, it will log, they'll give me a tag, and I will not call it on the main thread anymore. Okay, so like I said, the most common issues, network or disk operations, long calculations, then intra-process communication. So that's whenever you access a service in a separate process. This also involves some libraries like Google Play services. In general, try not doing IPC on the main thread. There are various costs involved here, like parceling and unparceling data, going through, through the system layer to reach the other process. And then the other process to respond to your query, to your request, can actually access Discord network, and it's out of your control. So try doing it on a separate thread. And now there's one more very common cause of ANRs, and it's not even because it takes a long time to synchronize on an object or lock and unlock something, but it's whenever you're doing multi-threaded programming, it's very easy to just create a deadlock. And if you and then there's slow broadcast receiver handling, which I'll talk about in a bit. So what's a deadlock? I didn't want to this could be a whole different talk, but so I didn't want to go into too many details. A classic deadlock example is if you synchronize on two resources and do it in the wrong order. Now, if one thread locks the first one, and at the same time the other thread locks the other one, now they will both be waiting on a resource that will never be possible to get control of, because they both lock different things and now they wait on each other. So essentially they're in a deadlock. Neither thread can move forward. And this is a situation you will probably only see whenever you work really low level with synchronization and multi-threading. If you maybe use libraries that help you with that, you will not encounter this. But if you do, then that's where the vitals section on the Play Store comes in. If you actually click on any of the ANRs, you get this trace dump that's generated on the device whenever an ANR happens. And it can tell you a lot about states of the threads in your app and what they were doing. So I know this is a wall of text, and it's sometimes really difficult to know what to do with it. So I suggest if you have a deadlock, then if you see the main thread has locked something and is waiting on something else, then you just Control F, search for this or this number. It's literally just the address of the object in memory that is either locked or trying to be locked. And then if you find it again anywhere in the trace, so for example here I have this thread 10, it's probably some kind of background task that I'm running, and it's waiting to lock, right? It's waiting to lock an object that was already locked. And then this one is waiting on something that's probably locked somewhere else. And they just can't move. So this is how you use these terrible, scary traces to debug these really difficult to find and difficult to handle deadlocks and other problems like thread starvation, live locks, and so on. I suggest you read about it. And every programmer should know how to do multi-threaded programming, but it's literally best to stay away from it and use whatever the facilities the system gives you or the libraries that you use give you to not have to deal with those things. And I mentioned that the last way you can cause an ANR are broadcast receivers. So a broadcast receiver usually runs on the main thread. If you, it runs on the main thread if you register it in your XML. You can do other things from code, but normally that's how we use them. And since it runs on the main thread, you should never perform long-running operations in it. And there's a similar timeout like for the UI. So if broadcast receivers are not something that a user really sees because they don't have a UI, but there is a timeout of 10 seconds, and doing something in a broadcast receiver for too long will actually jank your UI, and again, the device will seem frozen or sluggish to the user. So if you're handling the onReceive method of a broadcast receiver for more than 10 seconds, the system will kill it, and we'll get an ANR. So what to do with it? Well, broadcast receivers are supposed to be very simple components. You get broadcast, which notifies you about something, and then you either show a notification to the user, or you schedule some work to be done later, like not right now. But sometimes, even to show this notification, or sometimes to schedule this job that will happen in response to some signal, some broadcast that you receive, you might need a tiny little piece of data, either from the network or from the disk. Let's say you get a GCM message that says you have new messages, but you didn't actually put the message in the FCM message. So you have to connect to your server, download the message for your app, and then show it as a notification. Well, that's network access, so it's too long. I can't do it. So the solution is use goasync. Goasync is a method on the broadcast receiver. You can call it from onReceive, and it lets you keep the broadcast receiver open for a little bit longer. It lets you go off the main thread, so you create your own thread, you do some kind of async operation. And then, once you're done with your work, you have to call finish on the pending result that you get from this method. So when you call goasync, you get a pending result. You spin up a separate thread, do your work, and then call finish. And you have to call finish, and also in a reasonable time. And this might be 30 seconds, 60 seconds. So you shouldn't treat it as something like really long running, like a service, but it lets you do at least some I/O, like disk I/O, network I/O, or even some kind of longer calculation. So yeah, but what you normally do is then just create a job and schedule something for later. And I will talk about it in the battery section later. Okay, so let's talk a little bit about crashes. So crashes happen a lot, and that's because either we missed something while we're dealing with, again, threads or activities or lifecycle, and we try to code defensively. We do a lot of this ugly code. We check for nulls 5 times, and then we try to track the lifecycle of our activities and make sure that our UI is still active. Don't focus on that code too much. It's like fake. It just shows that we reinvent those things, and we do all the things we can to just make sure we don't cause an exception that will crash our activity. But it still happens because we are humans and we can't just predict everything that happens. So what can we do about that? Well, I suggest not trying to reinvent the wheel. Some time ago at I/O, we announced these architecture components, and why we created them was in response to what developers like you were telling us. So life cycles are hard. Activity life cycles, fragment life cycles are hard to manage. Database handling, persistence is also hard. There's a lot of boilerplate. If we were to write this every time, and every app does this differently, then there's bound to be errors somewhere. And so we created these. We hope you use them. We hope you like them. But you can also use libraries created by someone else, by your own company or other third-party libraries, as long as someone really took care about these things that I mentioned and caring about not crashing your app. And it's way easier to do that if a library has many users, if it's actively maintained. So just don't try to reinvent everything. Use the things that work, that make your lives as developers easier. And actually, we've heard that in app navigation, handling up and back buttons, the stack, activity stack, deep links, and all of those things are super difficult. So I really encourage you to, if you're interested in that, to tune in on the live stream, or if you're at Google I/O, to go to that session about in-app navigation. And here my colleagues will tell you all about how to solve that issue, hopefully once and for all, and it'll be really great. So I really encourage you to watch it. Okay, the other thing, so obviously I can't cover every reason why your app crashes, because for every app it will be something different. But I'm just trying to give you some advice that will maybe make your apps a little bit less crashy. And one of these I found is Kotlin. So we announced Kotlin as a first-class language on Android, also at I/O last year. And obviously it's a great, fun language to use. We all like it. Most of us use it already, either in hobby projects or even in production in apps. And there's a lot of great things about it. But in this context, I just wanted to mention, if you haven't used Kotlin before, it has null safety. So Java doesn't have this notion of nullability. Every variable that can hold any kind of object of a class can also be null. And Java doesn't really make you think about that. Now, we can add stuff like annotations, like nullability annotations to Java, but it's not a feature of the language. So we only have tools that make it better for us. Whereas in Kotlin, it has this nullability built into the language, and every variable that you declare has to be specifically made nullable by this question mark. So, and then once you have that, if a variable can actually be nullable, then it guards you against calling stuff. So I can't just read the background of this view because I don't know if it's null. So there are many, many ways in Kotlin where it'll actually make you check and make sure that the operation is valid, and it will not compile, it will not let you do that if it's not. And then similarly, if a view is not, it's not possible for it to be null, then you can be absolutely safe that when you call something like this with just a dot, that will not crash. So I really encourage you to try it. Kotlin is super interoperable with Java, so you can literally just start adding code in Kotlin to your apps if you haven't done so. And then the last thing, there's this account that my friends and I really like on Twitter. It's called Bad Android Advice, and that's what it does. It just gives very bad advice about Android programming. And one of these was an idea for a talk. Private APIs, a hidden treasure. So what are private APIs? They're basically the APIs on Android in the SDK that we never intended you develop for you to use. They're either marked as private or hide, and you can't see them like when you use code completion in an IDE. You can't actually call them, but you can do it with reflection because they exist somewhere on our phones. So this slide is all about changing that advice and telling you just say no. And going back to that, Android vitals and living organism analogy, private APIs are a little bit like a drug. So you think, well, Android doesn't let me do these things, but I know it's there. They did it in the code base somewhere, but it's not exposed to us. So I'm just going to use it by reflection. And now my app gains superpowers. It's great. Everything works. I'm hooked on it. And then a new version of Android comes out, or a manufacturer releases a phone where they actually changed this, or you removed it entirely. And suddenly your app breaks for everyone who upgrades. And that's because we never intended for these APIs to be actual APIs. So it's not stable. It's an implementation detail. We can change anything about private and hidden methods because you are not supposed to call them. And that's why in Android P, we are restricting the use of non-public SDK interfaces. So read about it more in the documentation in the preview section. And we're going to be doing that in phases. There's going to be a blacklist of things that you're never supposed to call, and they will just crash if you try to access them by reflection. And then there will be various gray lists and white lists for APIs that currently just don't have something you can use instead. So even our support libraries or Espresso currently are using some hidden things. And what we want to do is in the future provide public APIs for those things that we deem as necessary for you. And then we will blacklist the private APIs. By the way, this is not the first time we're doing this. It's similar how Android Nougat prevented you from using NDK stuff, like native libraries that were on the system but were never exposed in the actual NDK. And that's because with the multitude of devices out there, we cannot guarantee that some SO file, some shared library somewhere on the file system will exist. It's just not possible. That's why we do these SDKs and NDKs, to tell you exactly what as developers you can expect. And the last thing I want to mention in the context of dealing with crashes is Firebase Crashlytics. So it's great that we show you, what crashed and what the stack trace was, and then you can go and try to figure it out and try to fix it. But sometimes that's just not enough, and you need context. You need to know which users' actions led up to the crash, so you can reproduce it or even debug it better. So it's super easy to integrate Firebase Crashlytics into your app, and it gives you a lot more information about the crashes. It integrates with analytics to give you something like a user journey towards the crash. And then you can add custom logs leading up to the crash. You can just log more things and then look at whatever variables you had there. And then you can monitor non-fatal exceptions. So, a crash happens only when there's an exception that actually is not caught and crashes your app. But you can just, if you have exception handling in your app, if there's something wrong but you caught it and you maybe recovered and your app continues working, but you can still monitor those and just it'll let you know what's happening on users' devices. Okay, moving on, we're going to talk a little bit about battery. So there are two main vitals related to battery and Android vitals. And the first one is stuck wakelocks. So what's a stuck wakelock? A wakelock is something that prevents the device from entering the deep sleep mode. So it usually just keeps the CPU running. It lets code execute. Even if the screen is off, there are also wakeups that can keep the screen on. I'll talk about it. But basically, a stuck one or a leaked one is one that was acquired, and it just stays acquired, stays on for a long time because you forgot to release it, or something crashed, and again, your code that releases the wakelock never executed. And then, the CPU keeps running. Every app's system, every app on the device keeps running, and it just drains the battery really fast. So again, I prepared some code that's really wrong, and there's so many things wrong about this that, well, let's go with them one by one. So here I have an activity. On start, I acquire a wake clock for this activity, and then on destroy, I release it. So, okay, what's wrong? First of all, in order to use vitals, and for vitals to be able to show you these wake clocks, the tags have to be static. That's for privacy reasons, because in order to correlate the sessions, like I said, from different users' devices, we want to have as many of them as possible. So the tags have to be the same across devices. So here I'm doing something relatively harmless. I'm just putting the memory address of this activity, maybe for my debugging purposes, whatever. But I shouldn't be doing this. What if I were putting a user's email address here? That would be really wrong. I don't want to see that in the console. So just stick to something static like my app main screen, and that's it. And now I will know this tag is always coming from here. The other thing, there's a lot of wakelocks that are deprecated. You should almost never use anything else than partial wakelock. A full wakelock also keeps the screen on and so on. So I should just not use those deprecated variables. Then when acquiring the wakelock, I never set a timeout. So there's a leak about to happen, right? If I set a timeout, then whatever I do wrong, at least I will release it after whatever seconds that I set here. And finally, well, of course, I'm a terrible developer, so I mismatched the lifecycle events. I'm getting my wakeups on start, but only releasing them in on destroy. So if I press the home button, come back to my activity, I will get a new wakelock, and so on, and I will only ever release the last one. So it's completely wrong. So what you should do is, you can't have a stuck wakelock if you don't have wakelocks. The worst thing about the last screen was that I was even getting a wakelock in an activity. You should never do that. If you want the screen to be on when the user is interacting with your activity, maybe I have my phone here, I'm cooking something, looking at a recipe in a recipe app, then just use this flag on the window on the activity to say keep screen on. And now the system will manage it for you. If I back out from that activity or press home or whatever, the system will just clear that flag and the device will be able to see. No code, no dealing with timeouts, try catch, and so on. So it's way better. And also, even if running things in the background, there are very few situations where you actually have to use a wakelock. So for example, if you schedule jobs instead of managing your own custom services, then the job scheduler will hold a wake clock as long as your job needs to execute for you. No need to create your own. And even with the old Alarm Manager API, it will also hold a wake clock for as long as you are in BroadcastReceiver on receive. And that's something we talked about, right? In on receive, you really quickly set something like a job or a notification, and you're done. Once you exit from that method, Alarm Manager will let your device go to sleep again. So try to avoid wake locks as much as possible. But if you find that you actually have to use it, like I said, choose a partial wake lock. This is, I think, the only non-deprecated constant on the Power Manager. Set a timeout value so that for whatever you do wrong, it'll still be clear. Give it a static descriptive tag so we can show it to you in Android Vitals. And use all kind of defensive programming like try finally to make sure you release the wake clock as soon as you're done with it. Don't keep it for too long. And there's a low-level debugging command you can use when you have a connected device. It's add shell dumps as power. And in the long wall of text that comes up, you can just find a list of wake clocks held by your app. So here actually, if you give it a descriptive tag, you can then kind of correlate it with whatever you're doing in code. And so for example, if you stop your service, if your app is not running, you should probably see nothing with wake locks. And we know it's not ideal. One more thing. There's also this tool called Battery Historian. It's on GitHub. It's seldom updated, but it kind of works if you compile it yourselves. The Docker image is unfortunately broken currently. The way you use it is first you enable this full wake history for your on your device. It's better to use a phone than an emulator because an emulator is always connected to power. And then once you enable this full wake history, you use your app for some time, usually longer than just 30 seconds. You actually want to see how it behaves over a longer period of time. Then you take a bug report, and then you open it with this tool. And for example, here we have this, on this timeline, we have user space wake locks. And so here you will see the periods of time whenever anything held a wake lock. And if you actually mouse over it, it will show you a list of wake locks that we collected, including your apps. But like I said, you will have to go and compile this tool yourself, and it's not very easy. And also the command I showed you before, this add dumps as power, it's not ideal, right? So we know about this, and we're trying to make it better. And unfortunately, I can't talk about it now, but expect more soon. It'll be easier. Moving on. Excessive wakeups. So in the last few versions of Android, even before Lollipop, but sorry about that. So in Lollipop, we introduced Job Scheduler, and that was a big new thing for running background jobs, any kind of background calculations that you need to do. And then we continued with new app restrictions in Marshmallow. There's those and app standby. And then even deeper those on the go, which kind of limits what your apps can do in the background and drain battery. Like they limit network access, or they don't let apps wake up the device as often, which we also did with limiting implicit broadcasts, like running apps whenever a photo is taken. And then in Oreo, we're introducing in more restrictions like background execution limits. So that means an app that is not in the foreground, it's not shown to the user, it has no UI currently, it can't actually start a service in the background. So what we call it is we are limiting free running services, which developers were often abusing for various reasons, and that drains the battery a lot. So the whole point of this exercise is not to make it more difficult for you or punish developers for something. It's actually all to make users' lives better and easier with Android devices. And for all of these, there are workarounds and actual better patterns to use than just blindly scheduling your app to do something every 15 minutes. If you ever, if you ever used Alarm Manager, there's various ways you can schedule things to happen at a certain point of time. But the ones that probably are to be avoided the most are those that are post-fixed by wakeup. These types of alarms will run even if your device is in a deep sleep mode, and they will wake up the device, run your code, and then other apps will also probably wake up and do something, and so on. So this is something we really want to avoid. So if you have to use them, like reduce the frequency, reduce the types of situations when you want to run this, and so on. Or better even just remove them, like remove all uses of wake up alarms in your app, if you can, and use other means. So what do I mean by if you can? Well, maybe this chart is not ideal, but at least it gives you some guidance. So you have a task that needs to be run sometime in the future. And it's not part of an activity, it's not something the user interacts with, it's some kind of periodic or one-time maybe synchronization or some basically bookkeeping that you do in your app. So is it a local work, like you need to process something that's on a disk maybe once a day, or maybe synchronize something with your server? Well, the first thing always to ask yourself is, can I use a job? If you can, great, it's done. Like I will talk about Job Scheduler. It's probably the best way to schedule anything. It takes care of synchronizing it with those periods and many other things. By the way, content providers existed on Android for a longer time than Job Scheduler, and it's also fine to use that. I mean, content providers currently are actually using Job Scheduler for the actual scheduling, and it's just that it's not for every app. It requires a lot of boilerplate. Only if you use the account manager and you have a content provider, then you can use a sync adapter, and that's fine. Then you don't have to rewrite it back into jobs. Okay, but what about things that need to run at an exact time? Like, let's say we have a conference schedule app, like for this conference, and I want the app to remind people to come to their sessions 5 minutes before. And so that's super important to run at a specific time. Well, then maybe use an alarm manager with the wake up alarms. Maybe that's fine, but remember to do it very sparingly, only if you have to. The better idea is if it's something triggered online, like a real-time message coming into your device because I sent you a text message or something, then you can use Firebase Cloud Messaging, and high-priority FCMs will wake up the device and deliver that message. But again, if you can, just stick to normal priority. If it's not something that has to arrive at a specific time, the system will intelligently batch the messages and only wake up the device once in a while. It's better for battery. And then if the user expects something to be happening right now and keeping the device running, maybe I should use a foreground service. Like if I set my navigation and put it in my car, I expect it to keep running because I'm navigating, I'm looking at it, I'm using it, so it's completely fine. And the thing about foreground services is that the latest versions of Android require you to show a sticky notification to the user. And that's why I'm saying it has to be something that the user really wants, because otherwise the sticky notification will be annoying. And if you got to the bottom here, maybe consider not doing it in the background. So for some time, I think years ago, we had this advice for like prefetching data so that when the user opens your app, they always have fresh data. But it turns out it's maybe not always something that's good for you. Like, why would I need to, let's say, download the whole newspaper content every night if the user only uses my app on weekends? Then every day I probably waste that data, I waste that processing power and battery to download that. So maybe think about lazy loading. Maybe think about not prefetching as much stuff as you should and just not hitting the background. And like I said, with intelligent job scheduling, so things like Job Scheduler, you get a lot of things for free. You get automatic backup and retry in case your job fails for whatever reason. Let's say Wi-Fi connection got lost. So you don't have to reschedule it again using something like Alarm Manager. It will be taken care of for you. You can set criteria like network or charging so that you don't wake up your device to download something from the internet if it has no connection. Job Scheduler will just intelligently only run your job when the criteria are met. And then it's compliant with those and app standby. So again, with those you get these short windows of time when apps can actually run and do their things. So Job Scheduler will only run you when it can. And like I said before, it has automatic wake-up handling. So a lot of this background processing is closely tied to what I was saying with wakelocks. And as much as you can, try to avoid having custom wakelocks and custom services, and use the facilities that do that for you. And there'll be more at I/O again. So there's this session on background processing, and it'll go in depth into what I was just talking about, and we'll tell you all the best practices on using background jobs. So I really encourage you to watch it. And then there's, again, so low-level system commands. So you can dump sys your alarms. So if you're using Alarm Manager, you will know how, what you have scheduled, and you can debug if you have too many alarms or they're running too often. And then there's one for job scheduler, which will list all the jobs that you have, including the criteria, such as charging false and battery not low and other things, and how often they run. And again, I know this is not ideal. This is like the last resort. And again, we are making it better, but I have nothing to announce yet. And I think I'm slowly running out of time. It'll be lunch soon, so I'm going to run through this really quickly. I said, I can't talk about rendering too much because it's a huge topic. However, we track two things. We track slow rendering, so this is whenever you get a small jank in your app when something's scrolling and it's not smooth. And we also tell you about frozen frames. So these are frames that are stuck for, I think, 700 milliseconds or something. So this is when the UI actually freezes for a long time and maybe even causes an AML later. And it's really visible to the user. And I really encourage you to try the Android profilers. We have a profiler for CPU, memory, network. You can see how long things are running. Like here's, for example, that Sudoku generation call, which if I use the profiler, I would immediately know that it's like super recursive. It takes a long time compared to all the other things I'm doing. And so I can see that I moved it on another thread. So if you haven't used the profilers before, I really encourage you to try it. There's some videos from me and from other people online that explain actually how to record this stack trace and how to look at it. And then there's a tool called systrace. And similarly to Battery Historian, it's not part of Android Studio. It's something that lives in the SDK. It's a really low-level tool for advanced debugging. And it doesn't actually tell you what's happening in your app. However, it does show you, whenever your app was running, what the context of the device was. Like, what were the CPUs doing? What other threads, what other processes were running? Or how many CPUs your app was scheduled to run on, or if you were blocked on I/O. And there's a session from last year I/O, so 2017, from Tim Murray, I think. So I really encourage you, if you ever want to use systrace, and it's a good tool, to watch that session, and it explains the UI and everything. And there are some other vitals that I haven't talked about. So there's also excessive background Wi-Fi scans and excessive background network usage. So that's also something that's currently available in Android vitals. It's, again, deals with battery or just using resources too much, like maybe you're downloading too much data and your users wouldn't like that. So it'll alert you to those issues. And there are also things that are not part of Android vitals, such as APK size. APK size is pretty important. I've had 2 sessions that I know about it. Other people have talked about it. The important part here is to understand why your APK is large, to track your size and spot regressions. Like maybe in one commit, some developer on your team added a dependency that suddenly brings your APK size up by 20 megabytes because it has shared libraries and stuff. So it's really good to care about that and use the APK analyzer to just look at overall app size, resources, code. The DEX viewer since Android Studio 3, I think, or 3.1, also shows you code size, so DEX size per package, class, and method. It lets you see how much each dependency more or less brings into your app. And then there's even a command line tool that you can integrate with your CI or basically integrate in your developer workflow to spot these regressions and track your APK size over time. And another thing that is super important for how users perceive your apps is application start time. And I don't think it's not part of Android Vitals currently, but you can use basically profilers and systrace, and even just running your app on an emulator. Whenever it draws the first frame of an activity, it displays this message. You can look at this and see if this value is too large. Well, 3 seconds is probably way too large for an app. And then think about removing stuff from your application on create, reducing the number of content providers that you have in your app, because content providers are actually eagerly created before all the other components in your app. And try to bring this value down. And if you're loading a lot of stuff asynchronously, so let's say this time is really low because the UI shows very quickly, but my list view with whatever, a list of articles is empty because I'm still hitting the network and reading them or reading from a database. You can actually report from the activity, call this method, and report why it's fully drawn. So once I actually finish loading asynchronously my content, I do this, and I will see a similar log telling me when my app actually finished loading and is shown. And then you can think about ways to reduce it. And remember, there's a whole set of tools at your disposal. Like I said, Android profilers. There's something called the pre-launch report on the Play Store. It's kind of like separate from Android Vitals. It works for apps that you upload to the alpha and beta channel. And what the pre-launch report does, it runs your app on a preset set of devices and emulators, and it tells you all kinds of things also about stuff like APK size and crashes, and it just basically is like a test track just to spot errors early on before you actually release them to the production channel, to the main channel. And then, like I mentioned, APK Analyzer, Index Viewer for everything related to APK size and what's inside your APKs. You can choose to use Firebase Performance Monitoring. It gives you a lot. So if I had more time to talk about that rendering section, that's where probably I would mention it. It lets you report a lot of stuff about janky frames and the smoothness of your app, and report it back to your server so you can actually run some analytics on that and try to fix it. I mentioned crash edits, and then we're also adding more stuff to the Android tools, so things like D8 or R8. So D8 is a replacement for the Dexer, for DX, which just by using it, your app might get a little bit more, a little bit smaller and a little bit more faster because it produces optimized Dex bytecode. Same with R8, which will be a replacement for ProGuard, which I hope you're using in your apps to reduce size. And we're gonna probably talk more about R8 during this I/O. So thank you. This is the short link for the documentation pages for Android Vitals, and I'll hang around during lunch if you have any questions. Thanks.